All right, so this is going to be, let me see if I can get a full screen here. There we go. This is the last page of the final exam. I've been meaning to do it for a while. I haven't gotten around to it. I'm going to try to get it done today. And it's mostly graphs, and I don't teach transformations. I put a couple of notes down for myself so I can remember to say a few things. And yes, I do not teach transformations. Graphs are, you know, basically an infinite number of solutions to equations. Give me an X, I give you a Y, plot it. And how do you get good with calculations? You calculate. So I think especially for functions like e to the X and ln of X, you got to become familiar with some of the numbers. And then we'll do a shortcut here. And if you want to learn the shortcuts, I suggest you go to the playlist and look at some of the Rapid Fire 5 postings for quadratics and square roots, exponentials, so on and so forth. And how to kind of take the shortcuts are probably explained better there than what I'm going to do now. All right, so as I say, most of the problems, once I get past problem one here, seem to be all graphs. So well, one or two that aren't. All right, so let me erase this. And let's talk of finding f of a minus b if f of x is 2x plus 3. All right, so what is the function telling me to do? It's telling me to double and add 3. And I got to put something in to double. And in this case, it's a minus b. And so if I do that, I'm taking care of the parentheses, which gets me 2a minus 2b plus 3. What am I going to do? I'm going to do the f calculation, which is to double and add 3. And now this is what I'm doubling and adding 3. So I get 4a minus 4b plus 6 plus 3 is 9. Okay, so that takes care of that. Writing this as a single logarithm might be easiest to see if you write this as the opposite of the ln of 5 plus the ln of 3. That might be the easiest way to get started, because that's the subtraction of ln of 15, right? Multiplication implies an addition of exponents. And so I'm subtracting, which is really minus 1 times the ln of 15. And we talked about in class that you can look at power to power by putting that minus 1 in the parentheses. And so that's a reciprocation, 1 over 15. And that's your answer right there, a single log. Now, I'm hoping you do know that the ln of 5 is approximately 1.6, the ln of 3, 1.1, so that's 2.7. So this is approximately minus 2.7. And on the ln function, 1 gets you 0. And this is x equals 0. So somewhere in here is 1/15. And it's getting us a negative value of negative 2.7 roughly. That doesn't hurt to know that. The shortcut for finding the period of the function is to take the multiplier and divide it into 2 pi. That means 1 revolution takes 20 units. Now, what is that in terms of actual distance? Well, 2 into 20, 10. Pi divided by 10, 0.314 roughly is the distance from here to here. Because that's, once you get there, you got repetition. It's the same distance from here to here. Down, down, okay? Now, showing where that shortcut comes from, doesn't hurt to see that again. I'm a big fan of repetition, and we've done this repetition throughout the semester, and it's the last chance I'm showing it on this video. So we're setting 20x to 0, and we're setting 20x to 2 pi. All right, sine function starts in the middle, goes up in the first 90, comes back. So that is the period, that distance from here to here, and I'm saying that's 3.14. Why? Because x equals 0. So this thing starts at 0. I guess 11's the middle, 5, 0 gets me 16, and back over here, approximately 0.314 as a decimal is going to bring me back to a height of, 11. 11, all right, the range goes up 5 and down 5, so that's 16 to what? 16 to 6, okay? There, that looks a little better. So we solve this and we get 1 revolution, 2 pi, every 20, and then just repeating what I did a minute ago, I think. Well, maybe I didn't repeat it. pi over 10, I think I did, yes, yeah, 0.314. All right. I got to make sure I show that better. I don't have Rennie the cart with me. I don't know where Rennie is. Taking a vacation in the summer, maybe. Lots of ways to write these, but I'm seeing, what do I want to show? I'm going to show this as in a sine function. And the sine at 3 pi over 2 is a -1, and I'm going to use that right now. 50 to 100, so I'm going to start with 75, and I'm going to go up 25, sine function, but that's going to turn into a negative in a minute. Okay, what do I have here? I have 2010, I want to act like 3 pi over 2. Okay, so that's not hard to do. X minus 2010 plus 3 pi over 2. So when I put 2010 in, I get the sine of 3 pi over 2, which is -1. -1 times 25 is minus 25 plus 75, bingo. And I can see that I've got 2010 to 2040 is a change of 30 units. And what happens? I get one revolution, which is 2 pi. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And you can certainly reduce that fraction and get yourself 2 pi over what? Right? If you set the multiplier, 5 pi over 30, that's 2.5 revolutions. Well, what's it take? You got to figure out what that distance is for 1 revolution. And I could keep going, but let's keep moving here because that problem has been solved. All right, y equals 10. My first differential is 10 to 50, which is 40 units. The next one is not 40 units. The next one is 10 to 90, which is 80. So I have a doubling function here. T minus or x minus 1903 allows us to use the fact that b to the 0 is 1. So I just made a 0, which makes this 1, and 40 plus 10 is 50. Bingo. That takes care of that. And then it doubles every what? 1903 to 2097 years. Hopefully I'm not making any careless errors as I go along. So that's that function. You can doctor that up a little bit. So logarithm here, increasing log. So my base is bigger than 1. Let's get some space here. Final frontier. All right. So I'm looking at the differentials here too. From 4 to 7 is 3 units. And from 4 to 10 is 6 units. So I have a doubling function. But let's start with the first y I see, which is 50. The next y I see is 72, so I'm going up 22. It's a logarithm, asymptotic 4, so x minus 4 gets you to your domain restriction. You dropped in a 7. That gets you to your first differential. The next one is going to be 6, and so it's going to be 6 over 3, but we throw in a 10. 10 minus 4 is 6 divided by 3. That's why it's a base 2 log. Again, this is the end of the semester. That's what we worked on for months. If you're just timing in, go to the logs, go to the playlist, look at speed graphing logarithms, and you get some practice. But the only way you get good at this is to practice. It's the only way you get good at anything, I think, is how do you get really familiar with something? Yeah, practice. Unless you're Allen Iverson, and you're just darn good anyway. All right. All right, linear function. I can see a 5 and a -4 gets me 0, 0. So I'll just grab it. A 5 gets me a 4. That's with the x's. That's with the y's. -4, excuse me. -4 makes a 0. So we'll put that right over 5 down -4, right about there. We'll say 5, -4. And this is really 2 over 1 because this is written in point slope form, which means if I go over 1, I go up 2. Doesn't hurt to show that. Over 1 means 6. Up 2 means -2. You can always check it. 6, -2. See if it works. It should. There's your function. Arrows in both directions. Cup shape down. Vertex minus b over 2a. 24 divided by -6 is -4. So therefore, -4 is going to get me. Multiply that is positive 96, cut in half is 48. 48 plus 2 is 50. I believe it gets me 50. And a 0 gets me on the downside of things, a 2. Now let's just check that. Let's make sure we get -3. So how do I get from 50 to 2? I go down 48. Okay. And if I look at the change, -4 to 0 is a change of linear change of 4. Linear change of 4, but I'm squaring. And if I square, I get 16 units of change, and I don't think that takes me to 2. But -48 divided by 16 is -3. Corroborates that, so we're moving on. Oh, I don't have Rene. I miss Rene. Miss Rene Descartes. All right, what do we have here? Exponential function, positive multiplier times x, so it's exponential growth, asymptote of -4. And I know e to the 0 is 1, so I'm going to make this 0, and that comes from putting 1 in for x. So a 1 gets me a jump of 10 minus 4, I should be at 6. E to the 0 is 1, yes, 10 minus 4 is 6. And that's how far it is from -4 to 6, 10 units. I like that. I like to triple. So my next one's going to not go up by 10. It's going to go up by 30 if I pick the right number, and I want this to equal 1.1. So add 2 gets me 3.1. 3.1 divided by 2 is 1.55. Hope I'm not making any careless errors here. 1.55 doubled is 3.1 minus 2 is 1.1. E to the 1.1 is 3 times 10 is 30. Minus 426. All right. Minus ln function should look like that. So we plug in a -1. That's what my x equals, because this has to be positive. And so my numbers have to be bigger than -1. And I like the ln of 1, and I like the ln of 3. So the ln of 1 is 0, which means I'm going to get 2. So I'll just put it in the middle here. I'm going to get a 2 if I can make this 1. So 2x plus 2 equals 1. 2x, you probably can do it in your head. -1 minus 1/2. So -1/2 should get me 2. Let's plug it in, because you got to get familiar with this stuff. -1/2 times 2 is -1. -1 plus 2 is 1. The ln of 1 is 0. 0 times anything is 0 plus 2. Bingo. And now I want to get ln of 3. So 2x plus 2 equals 3. And it looks like that's positive 1/2. Positive 1/2 is bigger. All right, so 1/2 times 2 is 1 plus 2 is 3, and the ln of 3 is 1.1. Minus 2.2 plus 2 is -0.2, which is lower. And further to the right, I think we're good. If I make a mistake, somebody correct me. I'll just put it in the comments, the introduction, whatever. So what's the best way to do this? To know that the cosine of 0 is 1. Cosine measures the width in the unit circle, and the width is 1, and the width is -1 over here at pi. But we're going to use 2 pi over 9 and 1700. So 1700 makes a 0. 0 times anything is 0. And therefore, I am going to get the cosine of 0, which is 1 times 5 is 5, plus 10 is 15. Ow. And I do know that 10 is the center, and I do know I'm going up to 15, and I do know I'm going down to 5. So 9 units later should be bringing me right back to this. 9 units later, so 1709 minus 1700 is 9 units. 9 units cancel. I get the cosine of 2 pi, which is right back where I started from. And therefore, I'm back to 15, and we have a lot of symmetry here. So I know that that should be 1704.5. That should get me 5. Doesn't hurt to put that in and see how it works. We're not going to do that right now. We're going to do this problem next. And let's hope this is actually filming properly, because I haven't done this in a while. Took a break. Yeah, the old man took a break. But I did tell you I'd do this, so I got to get it done. I'll do another page tomorrow or the next day. Oh, this is gone. This is gone. So it doesn't hurt to write these in factored form, x plus 5, x minus 5, difference of 2 squares. Hope you recognize that. So therefore, boom, 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 and we got an x equals 5, we got an x equals -5. We can see that if you put numbers in, the bigger the denominator gets, the more it goes to 0, so that answers that. So y equals 0 on both sides. All right, and if you put big numbers in, bigger than 5, you got a positive. So it's got to look like this. There's got to be a sign change because there's a sign change at 5, at -5. All right, and so let's look at 0, -325. 0 gets you negative 3/25. All right, plugging in numbers, sign change. So it's got to look like this because there are no x-intercepts. All right, there's no way you can make this thing equal 0. You can try, go ahead and try to make that equal 0. But not going to happen. And so no x-intercepts, but a sign change. It's got to look like that. And you should take some time and verify. So why not throw in -10? -10 should get me a small positive value near 0. -10 squared is 100. -25 is 3/75. Yes, that's a positive number and it's getting close to 0. And if you want to get good at these, you got to put numbers in. And the more you do that, the less you have to eventually. Because you know the shapes of these things. So what is the limit of f of x as x goes to 5, as in I take numbers like 8 and 7 and 6 and 5.5 and 5.111 and 5.01. Well, if I put 5.01 right in here, 5.01, I start getting things like 3 divided by 0.000005, I think. That goes into that a lot of times, like an infinite number of times. Now, we can just look at the graph and we can say, when is it less than or equal to 0? Well, it's never equal to 0. But from -5 to 5, I got y values here. I got outputs. They sure look like they're less than 0. So what have I got here? I've got an answer of x is less than 5, greater than equal. Nope, not equal. Greater than -5. Did you see that? Yeah, guess so. All right, so I did throw a couple of, challenging questions in. Yeah, 139, as far as I was concerned. Darn good Algebra 2 score, and you got real good credit for that. But doesn't mean I couldn't challenge you with a few things. And we did start talking about how to graph these. So the square root of x looks like 0. Boom, that's what it looks like. Now I can't use 0 when I divide it into, so I'm going to put a little, can't use that number in this case. But now I'm dividing all of these y values. All these y values, which are going up very slowly. Going up very slowly, I'm dividing them into 1. Now what happens when I put a really big number and I take the square root of a big number? I actually still can get a big number. Square root of 10,000. 4 zeros. It's 100. And 1 divided by 100, pretty close to 0. Now, what happens when I put a really small number into 1? What happens when I put numbers in like 1/10? Oh, I get 10 out. So if I pick a number like 1/100, and I take the square root of 1/100, I actually get 1/10. And 1/10 goes into 1 100 times. So I just picked 1/100 and it went in 10 times. Well, I think I'm getting something that looks like that. All right, and you can check it with a calculator or some graphing function on the internet, right? And that's how you get good at graphing. All right, but I'm looking at that from the context of 1 divided by that function. And that's how I would have approached this. And so we have an asymptote here, x equals 0. All right, not changing much, 1/100, 1/10,000 is 1/100th for a square root. 1 divided by 1/100 is 100. So the x didn't change much, but the y just did. Asymptotic behavior. All right, we're getting there. Let's move the table. You can do the following graphs that we want to just get done and done quickly because you've done so much work. You know an absolute value, V-shape, 5 makes a 0, so that's going to get you a minimum because absolute value measures distance from 0, and probably other ways to describe it too. So very similar to the quadratic. 5 gets you 9. I like to put a 0 in, and 0's on this side of 5. And I can see I got 29. All right, so arrows, and you're done. This one, well, might take a little while. All right, so what do I see? I see the same exponent. We talked about that. So 4 divided by 2 is 2. So end behavior here is y equals 2. Y equals 2. I can see 10 divided by minus 6 is minus 10/6 is minus 5/3. So 0 gets me minus 5/3. I see that. I see that negative 10/4, which is negative 5/2. Negative 5/2 is an x-intercept. Gets me 0 for the value of that fraction. I see sign changes. Okay, so I definitely see sign changes. I see 3 makes a 0. So therefore over here, x equals 3 is an asymptote. Okay, we're done. I can see that trajectory, and I can see that trajectory. And that's enough for me. It's enough for you. All right, anything else to be said? Yeah, you want to get good at that? You got to put numbers in. All right, so let's put 10 in. Let's put 10 in. 40 plus 10 is 50. 20, 14. So 50 divided by 14, and that's a little less than 4. All right, now where is, what did I pick? I picked 10. All right, so somewhere in here, I'm bigger than 2, but I'm not that much bigger. All right, so I'm not drawing the scale here, but believable. I picked a number, got a little better feel for the calculation. Okay, I'm not talking about shifting y equals 1 over x, making it narrower. What? Not talking that way. I don't do transformations. You want to get good with calculations? Calculate. All right, we got a base that's less than 1 and an addition. So therefore, it's one of those decreasing functions. And again, I want to make this 0, so x equals 5. I want to make this 1. Okay, so that makes a 0. I get 20/20. So 6 gets me 20/20. All right, I want to make this equal 1/3. Because that's going to get me 1, which is going to get me 20/24, which is actually higher. 20, yeah. First off, I can see get 1/3, I need 5 and 1/3, right? 5 and 1/3 minus 5 is 1/3. All right, what do you put on top of 1/3 to get 1/3? 1. There's your 20/24. And I knew that, and that happened when x was 6. All right, so what? X minus 5, I see, right? I hope there wasn't anything else. So 6 gets me 20/20, and 5 and 1/3, I never did write it, gets me 20/24. There we go. All right, so that's done. Okie dokie. Takes care of that. I see exponential decay. I see an asymptote of 4. The decay, this is the decay. That's decaying. First it's 30, then it's 15, then it's 15 over 2. Those are the differentials. So 30 plus 4 is 34. 34 happens at, that's the y value, happens when I make a 0, and that's -1. Okay, and then I change by 5 units, so that's going to take me to 4. 4 plus 1 is 5, divided by 5 is 1. 1/2 to the 1 is a half. That means I went up 15 from 4, 19. Okay, and if you're just learning how to do this, you should put 15 halves. Well, you should pick the next number, which is another 5, 9. You should put 9 into this equation and see what happens. All right, 1 period of the cosine function, then I'll upload this. All right, so where do we want to start with this sinusoid? Let's start with, put a 6 in. That gets you the cosine of 0, which I hope you know from studying it this whole semester is 1. Cosine, remember, cosine is the width, cosine of x, sine of x, 1. Now, what is the width over here? Well, what happens to the width as I move over there? It goes to 1. 1 is the biggest fraction I can get out of this calculation. So that's going to be 5. I guess that's the number 5 plus 7 gets 12. And I know that the center of this is 7. And I know I'm going up 5. I'm also going down 5. So the range is 2 to 12. And I want 1 period. 1 period is the circumference of a unit circle is 2 pi units, 6.28 units. So I'm near 12.28. This is near x equals 12.28, but exactly 6 plus 2 pi. So let's see how that works. Let's drop 6 plus 2 pi in here. Okay, the 6 is canceled. The cosine of 2 pi is coming back to that width of 1. 1 times 5 is 5 plus 7 brings me back to 12. And then I own it. This is 3 plus pi, right? 6 plus pi, excuse me. 6 plus pi should be a very friendly number. You plug it in, see if you get 2 out. Yeah, it's good little practice. All right, so that was the last page of the final. I think we got another three pages at least to do to get all of those problems in front of you. But hopefully you followed that. If not, go to the playlist and practice because you need to know how to do all these things as you go up the ladder. All righty. I'll stop this and hope everybody's having a good day. It's a nice day out here. Let's take a look at the ridge. Look at that. It's not raining. Can't believe it. All right. Ciao.